Okay, then let's start with the instruction set again. I'm leaving few instructions right now because they will not be able to understood by you. But there are few instructions that we can understand right now, like LAHF. So LAHF stands for it copies the lower byte of flag register to AH. Fine. So always try to understand in that way. L stands for load, A stands for accumulator when AH means upper 8 bits, and F stands for flag. Fine. So lower load, upper 8 bits of accumulator from flag register. Direction is like this: load upper 8 bits with the contents of flag register, the lower byte first. Then vice versa, S, whenever you see S stands for store also. Store upper 8 bits of accumulated to flag register. It copies the contents of AH to lower byte of flag register. Just look for the direction. In the load, direction is from flag register to accumulator. Here in SAHF, AH to the flag register. Fine. Lower 8 bits. LHF, SAHF. Next is push F. Push flag register to the top of stack. Push the contents of flag register to the top of stack. जो stack का top location होगा, फाइन जो current top होगा, वो उसके top location पे flag register को push कर देगा. Pop retrieving from the uh, stack memory. If pop F is connected with pop F, that means it will retrieve it back to the flag register. So currently pointed location by the stack pointer will pop the contents of that location inside the flag register. Alright. So next we have the branching control. Fine. So before we go towards the branching, can anyone tell me, have you guys ever experienced branching phenomena in your programming? Anywhere? I know you guys have done a lot of programming, I suppose, but have you guys experienced that you are creating branching in your program? At what point you actually create the branches? You have already created a lot of times. I just want you to recognize the concept of branching. Do you recall where you guys implemented the concept of branching? You may call it something else that is quietly understandable and possible. Fine, but still, anyone in your
सर जब
programming? Yeah.
कंडीशंस लगाते हैं सर जब
Uh-huh.
if else
Definitely, that is one way of implementing the branches. Any other way?
The
Okay
switch
then. Yeah, please, please.
the switch case जब हम यूज करते हैं.
Definitely. That's what I'm saying. There are many ways to do that. I just want you to understand the whole concept first. Fine. So let me understand this thing even in the branching phenomena as well. Okay. So just bear with my handwriting.
yes sir.
All right, better. So let's understand branching in the branching phenomena. Fine. Branching with the concept of branching. Now you can understand why I'm focusing too much, because I want you to understand branching with the perspective of branches so that you can visualize actually how this thing can be actually implemented or it can be done. Right. So before we go here, let me put you towards more. Okay, so we have already created flowcharts where we used to start, then we have few boxes, then process box, input output box. There are a few different boxes we use, but there was a special box. What do we call this box? This particular rhombus shape. What do we call that? And inside that you put conditions. If That particular box is called your decision box. Fine. So what happens here is you put a condition inside the decision box. Let's say I'm putting a random condition. If a is equal to 0, a is just a variable. I'm checking the variable, a is having the 0 value. So there will be two paths. For true state, yes path, and for false state, no path. If the condition is true, that means it will follow the yes path. If it is not, then it will follow the no path. Alright. But again, if I'm checking something here, let's say I'm checking the second variable. If b is equal to 0, again it will be having two things, the true state or the false state. Whatever the condition satisfied, it will follow accordingly. Alright. Likewise, I can also put one more condition here. Let's say this time I'm checking for C. Is C having the 0 value? Fine. Again, two paths, yes path or no path. So are you getting my point? What do I mean by branches? So by branches, what we are doing, just try to understand the concept. We are transferring the control which was originally somewhere else. This was the original flow. Fine. We checked something at this point of time. Something arises. If the condition was yes, it will follow this path. If the condition is false, it will follow this path. Again, we created a checkpoint. Fine. According to the condition, it will again follow different paths. This place also. So, are you able to visualize what I mean by the branching right now? This is what I mean by the branching right now. That we are transferring the control from one location to another location on satisfaction of a particular condition. Fine. If a is equal to 0, go to the yes path. If it is not 0, go to the b path, no path. Again, I check. Then again, you can create a number of decision boxes. So by implementing a decision box in a flowchart, what we are trying to create here? By implementing a decision box, what we are trying to implement here? We are trying to create a branch. That is what simple. You have already done that. You just need to recognize what we have done actually. All right. Is that understood? What branching is? The whole concept behind branching is we need to transfer the control from one place to another place, from one memory location to another memory location. Is that clear?
Yes, sir.
This is the whole concept of branching. Then again, branching needs a framework. I'll show you the framework, what is available to you on the screen right now. That branching goes by two ways. In 8086 microprocessor, either you can use the jumping or you can use the call instructions. Fine. Further, jump, it is of two types. One type of jump is called unconditional jump. Unconditional jump. Second one is called conditional jump that you are watching right now. Fine. So after this jump thing, so let's understand first. In the unconditional jump, there will be no checkpoint and the control will not check anything while we are using the unconditional jump. It will not check. It will be simply transferring the control from one location to another location. What will be the instruction for this is simple JMP. Fine. And what is the syntax we have for jump instruction? The syntax will remain same for all of them. Jump instruction followed by the destination address where the jump should be established, which location. So this is the proper destination memory location where you want that jump to be established. Fine. If we are not knowing this value, then what? We are not always, you can not always remember all the locations in the memory until and unless you are having an expertise. So in place of this location, you can also use labels. You can create the label and you can connect your jump statement to that label. Or labels could be anything. It's like L1, L2, A, B, C, D. You can create your own understanding, loop 1, loop 2, loop 3, whatever. So jumps at that memory location can also be replaced by the labels. Fine. Now, this is the example for unconditional. That it will not be checking anything, it will simply provide the routing of controls. But once we talk, when we talk about the conditional jumps are always provided with few conditions. Now, what conditions we are going to utilize? I'll give you the simplest ones, the ones that we will be using most in our programs. Flags. Fine. Jump state or the branching statements mostly works with the flags as your conditional statements. How? See, J along with C. This particular flag means, or this particular instruction means, this is checking what it is checking. J stands for jump, C stands for carry flag. And what condition it will check? It will check carry flag is equal to 1. Fine. So what's going to happen? Just put it inside this box. This is the condition we are going to check. So how we do that? We do that like this. If carry flag is equal to 1, then after that there will be a location specified where the transfer or the location or the control will be moving only after the satisfaction of this particular condition. So JC means we are checking for carry is equal to 1. If carry is equal to 1 is true, it will follow this yes path. Fine, and it will connect to the prescribed destination. But what if this condition is true? Oh, sorry, it is false. Then what will happen in the program? The currently what you need to understand is once the condition executes, only after the satisfaction of particular condition, jump, carry flag 1, it will create the jump. But if it is not satisfied, the condition is not satisfied, then nothing is going to happen. The current instruction will not execute. The assembler will simply come to the next instruction. That's it. The moment a condition is not fulfilled, it is not satisfied, it is not going to do any kind of any more branching. No, it will simply come to the next instruction. That's it. Nothing to think more about it. Fine. So they will only execute when the condition is satisfied. So if carry flag is equal to 1, connect to this destination. If not, simply come to the next instruction. That's it. Is that clear? Is that clear, all of you? Okay, come to next. So in this, the next condition to check this carry flag is equal to 0. Same approach. Previously we were checking for carry flag is equal to 1. Now we are checking for if carry flag is 1. If carry flag is 0. If this condition satisfies, then the jump will be established. And same for 0 flag. 0 when Z 0 flag is 1, on which condition? When accumulator is having 0 value after an ALU operation. Okay, so that jump will be established when 0 flag is 1. Next, vice versa, JNZ, different condition. When 0 flag is 0, then only your jump will be established. These four, there are more than four. These are the basics ones I'm giving you. There are more, around 8, 9 more we are having. And so in total, 12 to 13 conditional jumps we are having. So what you can understand here that there will be a condition. If condition satisfies, then only the control will be transferred to the destination. Otherwise, it will come to the next location. That's it. And it follows for every instruction which goes through the conditional. Okay. Same phenomena. Almost everything goes same. with the call. Calls are again of two types, unconditional and conditional. With unconditional, you can see there will be no condition. You will simply write the instruction as it is, CALL call. After that, the destination location. Fine, there is no checkpoint here. But in the conditional calls, there will be some conditions to be checked like CC, CNC, CZ, and CNZ. Like we have discussed in the jump, same thing is going to happen. They will check for the condition. If condition is true, then the control will be transferred to the memory location given or the label given like this. CNC is for carry flag 0, 0 flag 1 for CZ, and 0 flag 0 for CNZ. Alright, is that clear? Branching. Any any doubt in this? Anyone? ब्रांचिंग क्लियर है सबको? Okay, then let's get back to the PPT. Is provided in the PPT. What we have already discussed, this same thing is provided in the PPT. Branching instructions again, call. Call is followed by the DES. DES is the destination address. Fine. This is unconditional call. Then we have return also. There is one instruction called return. RET return. Next we have JMP space destination again. This is unconditional. Then JXX. They comes under the category of conditional jumps. JC, JNC, JZ, JNZ. You can see some more. JA jump if above, JAE jump if above and equal, and which flag will be checking. Fine. So there are many conditional flags we know, and every time there will be a flag associated with everyone. There will be a flag associated. So you can use the flags to create your decisions. Then next thing comes is the loop instruction. Fine, and we know about loop. Loop is something which we want to be done repeatedly. If you want a task to be done repeatedly, we generally initiate the looping. Fine. So what is good part in the looping in 8086 is that loop instruction is associated with the register CX. Register CX. So if you want that loop to operate a number of times, just put that particular count value that you want your loops to operate, or it reiterate or get create this much number of strands. So that particular value will be loaded in the register C. Fine. So what happens in this whole phenomena, I have to make you understand in a different manner. Okay then. So you have an instruction loop. Fine. And loop is followed by again a destination. If you are not having any destination available with you, you can even use label. Suppose I used a label. Right now I'm using a label, let's say L1. Fine. So this means the instruction will be written like loop L1. Okay. So in the background of this instruction, which register will be operated? C register. Because that C register is having a value, let's say 4. So what is going to happen? If there is this body of loop L1 to, let's say this is end, and this is the body of the loop. And according to the loop, that means there are some instructions written in between, and we want that particular thing to create a stance or to repeat or to iterate for a number of times we are already giving in register C. So what happens? Just check. You loaded a count value 4 for the loop. It goes one time, one more time, third time, fourth time. Fine. So what will be the phenomena? आपने loop start तो कर दिया. Once you use the instruction LOOP, it will start the loop. But when the loop will stop, the loop will stop when this particular value reaches the zero. And what will be telling us, who will inform that this particular C value has reached is terminal value. Terminal means the zero value. So that particular job will be done by your zero flag. When zero flag is turning itself to 1, that means your C register has now reached the zero value and your count value for loop is finished. If this thing happens, the loop will come out and it will store whatever the value you know about it. You store the result in some way. It goes like this. Fine. Understood? Is that clear how the loop thing works? You know
Yes.
already, this is how this thing works. In the end of the loop, we check the count value. Is the count 0? If yes, exit. If not, go back, repeat, go back and repeat. So it's just we are checking the count value in the end, whether the count value reached the zero value or not. If not, repeat the task. If it has already reached the zero value, there is no more counting space available. Just exit and store the result somewhere. Fine. So is that clear? Looping instruction?
Yes, sir.
All right. So this is how the loops will take place, which will directly control the machine. Machine, the moment I say machine, it means the microprocessor 8086. It will directly put impact on the 8086 microprocessor. So which instructions we are having? HLT. HLT stands for halt. Once you start programming, you know how to write the instructions since from the beginning, start and all, data transfer, data receiving, processing, adding, multiplication, divide, whatever you want. But when the program will finish, how the assembler will be knowing that this is the last instruction of the program, and from where the assembler needs to stop reading. Assembler will not move further from this instruction. So HLT is that instruction, and which should be the last instruction of your program always. Fine, it is for the machine or the processor to enter to the halt state. Stop. There is no instruction further. So when it happens, the actual instruction which actually uh, runs in the architecture is called stop processing and wait. This is the actual instruction which flows the moment a halt occurs, is called stop processing and wait. Okay, so HLT will always be your last instruction. There are few more instructions which can stop this HLT, but they have to be in the form of interrupt or reset. Alright, so next is no operation. There are times we want the processor to enter into the wait states. Wait states for maximum of 3 cycles. So if you want that particular amount of time of 3 cycle, you can use NOP any number of times. Every time NOP executes, it will give you the time of 3 clock cycles. Fine. But if you're looking, the processor should enter the ideal state where it can also be waiting. So that time, the actual machine control instruction is called wait. It will add few more NOP, 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 and it will enter the system into the wait state. Next we have lock. Lock we have already studied. It will just prevent other processors to take control of my processor, and it can be used. Next we have the flag manipulation instructions. That in that instructions we can even manipulate the flags. How we can manipulate the flags? Like, look at this. STC stands for set carry flag. You can even set the carry flag even if it is not required or it is not in the ALU ऑपरेशन बट स्टिल आई वांट टू सेट सम कुछ कंडीशन ऐसा आ गया है कि यू वांट टू स्टार्ट द प्रोसेसिंग फ्रॉम carry flag is equal to 1, then you can set it. Same thing, you can also put it to 0 by clearing it. CLC means clear carry flag. Last one is CMC stands for complement the carry flag. If carry flag is having 1, it will be turning itself to 0. If it is having 0, it will turn itself to 1. Complement carry. STD and CLD we have already seen. This is for direction flag, set direction flag, and clear direction flag. STI for interrupt flag, set interrupt flag to 1 STI, and CLI clear the interrupt flag to 0. Next we have the shift and rotate instructions. Shift and rotate instructions, I'll show you graphically how the shift and rotate instruction works because they needs a little bit of workout. They're very important, by the way. Fine. So last we have is string manipulation instructions. These are very special type of instructions. They have to be used in a very different form of understanding and programming. Okay. How we generally notice a string or just the string is being stored in the memory is in the sequence. A sequence of bytes of words stored in the memory are generally considered as string, and that we need to use in the programming. By employment of strings, by using strings in a program, it actually reduces your size. The program will be shortened by utilizing the strings in this. So what instructions or what benefits we have or the formats we have here is 8086 instruction set includes the operations which are string movement, comparison, scan, loading, and storing. These are few operations we can perform with string. Next is REP stands for repeat execution of string instructions. So if you want the string instruction to be repeated, just put a REP in front of it. Next, every string instruction will have a capital S associated with this. It's like SB or SW. SB stands for string byte and SW stands for string word. Okay, so strings will be governed by two things. One thing is called direction flag because direction flag is associated with the strings only. But it is flag. We need pointer also. So the which pointers will be operating here? SI and DI. Index, source index and destination index. That index registers will be acting like pointers here. So along with the whatever the status we are having of string, the status of direction flag SI and DI, that will be updated on processing of string every time. Every time you process the string, their contents will keep updating. Right. So direction flag is equal to 0. In that case, SI and DI will be incremented. If it is 1, then SI and DI will be decremented. It goes like that. So whenever we see the string instruction, just look for this move S, move SB, move SW. There will be a capital S everywhere. Load S, STOS, STOS, comparison of string, scanning of string. So every string operation has a particular S phenomena inside it. So these are more practice based stuff. More you practice, more you will be close to these instructions, and you will have more expertise in programming and other stuff.